Hi. So let's look at a question that is closely related to series solution for differential equations. Okay, so just in case you are new to this, they said series solution for differential equations. It's just one of those methods that you can use to determine the solution of a particular differential equation, which of course depends on the type of differential equation that you have. Of course, you can use it for a good number of differential equations, if not all of them, which of course you can also use other methods just to confirm. So now the idea here is if you look at the question that we have, the question is asking us to show that this series that we have here is equals to this one, and it's also equals to what? This one here. So for us to show that those three series are equals to each other, as in they are the same, they have to start from the same point. What do I mean? The starting point for M, the starting point for J, and the starting point for S needs to be the same. If it's 2, let all of them start from 2. If it's 1, let all of them start from 1. If it's from 0, let all of them start from 0. And where they start from, there are no restrictions. It's up to you to choose. Okay, but of course for this question I'll have to choose to start from 0, which is like more like the one of the common starting point for a good number of series. Okay, so for us to do this, and another thing that we have to do as well is that we have to ensure that the index for x here is the same. What do I mean by being the same? If here I need to have x to the power m, meaning here I need to have x to the power j, here I need to have x to the power s. Okay, I don't really care with the fact that I have m, j, and s, because those are just letters. I can use z, I can use n, I can use w, or anything. Those are just letters. Of course, we know what they represent. Okay, so the method that we use to do this is called shifting. In case you're not familiar with what shifting is, you can watch the video that we did. I'll leave the link in the description below, where we did a question that required us to do some shifting, and that's why it was very important that we do that, so that any question that we do that comes after that one, it will be okay with you, because you are well familiar with how we go about shifting, which of course is very, very important and interesting at the same time. So let's go ahead and look at this one. So what I want to do here is that I've made a choice to say I need to start from 0 at this point. This one is already set to 0, so I don't think I need to make any changes. So I'm only making changes for these two here. Okay, so I need to start from 0. So how do I really start from 0? Or if I don't want to look at it that way, I can say, okay, I need to make the index for x there, or the power for x, to be m. So how I make it to be m is that I need to substitute where there is m here. I will substitute with what? M plus 2. Okay, m plus 2. And it is the same thing. If I want to make this a 0, I need to substitute where there is m. I need to put m plus 2, which will be equals to 2. When we subtract 2 on both sides, you find that your m is going to be what? 0. So it starts from what? It's going to start from 0 there. Okay, so we are going to substitute anywhere where we have m. We are going to substitute with what? We're going to substitute with m plus what? M plus 2. So what you're now going to have is that you're going to have uh, let's say summation. Okay, so we still have the infinity there. Then our m is equals to 0. Okay, just write this properly. Okay, that's better. So we still have our infinity there. Then we have observed that our m is going to start from 0. So how it starts from 0 is that where there is m here, you just substitute with m plus 2. That is going to give you m is equals to 0. Then where I have m here, I'm going to substitute with what? With m plus 2. Then here where there is m again, I put m plus 2. So you're going to have like m plus 2 minus 1. That is going to give us m plus 1. Okay, so that would be m plus 1 there, which is simple math for you, I guess. So we have a sub m. So where there's m, we are just going to put m plus what, m plus 2 there. Then we're going to have x, where there's m here, if you substitute with m, you're going to, it's going to be something like m plus 2 minus 2. Of course, that is going to be that's just going to be m. Okay, so now this is equals to, so we are done with this one, and we observe to say this one is equals to this one. How are they equals to each other? I have m plus 2, I have s plus 2. I have m plus 1, I have s plus 1. I have a sub s plus 2. Here I have a sub m plus 2. Then I have, oh, this is supposed to be m, like that. I have x to the power m, same as x to the power s there. So now let's look at the middle part. Okay, so we have our infinity sign there. So now the question is, for me to make this to be x to the power j, what do I need to do? I need to substitute where this j, I need to substitute with what? With j plus 1. Okay, because if you come and say j plus 1 minus 1, you're going to have j. Okay, so now we know that we're going to be substituting with what? With j plus 1. Okay, so if you put j plus 1 here where this j is equals to 1, you're going to have j being equals to 0, so meaning our starting point has turned out to be 0. So I say open bracket. So where this j here, we put j plus 1, so that would be like j plus 1 plus 1, that is going to be j plus 2. Then there we have our j here, which is j plus 1. Okay, then we have a sub j plus 1, but where this j here, you put j plus 1, you're going to have a sub j plus 2 there. So this is going to be x to the power, where of j you put j plus 1, that's just going to be j, and this is going to be equals to what? This here. Okay, so I guess I can just copy it and bring it down here. Okay, there we have it, and we can clearly see to say these series are now equals to each other. But what's really catching about the question is that it is just teaching us more of how to shift the index of the a given power series, because uh, as I earlier said, we're going to be using shifting a lot as we find series solution to differential equations, and it's very very important that we are well familiar with that, so that when you start solving questions on that, or as we solve questions on like when you find a differential equation, you want to find the solution using series method, it will be much easier for you. So that's basically how you go about that one, and that will be all in this video. Thank you very much for watching.